the presence of temporal constraints in a much more fine-grained way. The separation basically gives us three different types of hierarchy. The first one is I hierarchy, which is simply a hierarchically related roles where senior inherits junior's permissions, but user who is assigned to a senior does not automatically cannot activate the junior roles. He can inherit the permission but cannot activate the junior roles. Role activation hierarchy is the dual of I hierarchy. Here, senior does not inherit junior's permissions, but anyone who is assigned to the senior can activate the junior. So he can, in effect, use the permissions that are available through juniors, but he has to actually activate them. So it has implications in cases where you use auditing system to determine accountability and so forth. And one other advantage with this kind of separation is you can specify separation of duty constraints on roles which may be hierarchically related, which was not possible when we employed single hierarchical semantics, which is actually the semantics given in the last one, IA hierarchy, which is the most common. If you look at standard RBAC model, that's the semantics employed. That is, senior inherits junior's permission. A user who is assigned to the senior can also activate juniors. Now, we talked about the different semantics that can arise. If you look at this diagram, you have software engineer role and programmer role, assuming that software engineer role is senior of programmer role, and P sub P is the permission set that is available through programmer role. Assuming that blue line interval indicates the time when the senior is enabled, and red indicating the time when the junior is enabled. So we have cases where we have tau 1 and tau 2. How do we attribute the semantics of inheritance between these two roles? And to capture this, we introduce strongly restricted and weakly restricted temporal role hierarchies. In strongly restricted case, we allow inheritance to occur only when both the roles are enabled. So in tau 1, if you have inheritance hierarchy, the strongly inheritant, restricted inheritance hierarchy denoted by IS, a user assigned to the senior role SE is not authorized for permission PP in the interval tau 1 where only the junior role was enabled. Similarly, if you look at activation hierarchy, it applies to the second case, that is, a user who is assigned to the senior role cannot activate a junior role in tau 2 because junior role is disabled, although senior role is enabled. So this is much more fine-grained semantics that we were able to capture. Similarly, if you look at weakly restricted, we do allow inheritance even though both the roles are not enabled at the same time. For example, if you look at I hierarchy, where permission inheritance is allowed, a user assigned to senior role is actually, I believe it's a typo, is actually authorized for PP in tau 2. Oh, that's fine. If you consider inheritance with weakly restricted semantics, this should have been actually not his typo there. Even when both the roles are not enabled, you do allow inheritance. So even in tau 2, where the junior role was not enabled, you allow permission of the junior role, however, to be used by the senior role. And similarly, in activation hierarchy, a user assigned to the senior role can activate, even if the senior role is disabled, the junior role. So by virtue of it being assigned to a role, even though that role is disabled, the junior role is available to the senior role. And what's the usefulness of this different sets of hierarchies? Here's one example. If you have day doctor role and night doctor role, and if you want to be able to have a part-time doctor role which can be a role that overlaps the two intervals like daytime and nighttime, you can efficiently represent this as a policy. If you look at the part-time doctor role, you have those greenish intervals indicated there, and the red indicates the day doctor role from 9 a.m. to 9 p.m. and so forth. So if you have strongly restricted inheritance hierarchy, and if you have a part-time doctor role, which is enabled from 3 p.m. to 6 p.m. and 7 a.m. to 10 a.m., you can easily capture this requirement, because by virtue of the inheritance being strongly restricted, if you look at 7 a.m. to 10 a.m., that interval for part-time doctor overlaps with day doctor and night doctor. So it automatically can retrieve the day doctor as well as night doctor role in the two sub-intervals. So you can have this high-level policy easily implemented in hierarchy. Also, we have a very long list of separation of duty constraints that can be expressed to capture different requirements. Actually, we have grouped that into these 6 categories: role-enabling SODs. For example, you could say a particular group of role from a particular group of role. Maybe you want to make sure that node 2 is enabled at the same time or disabled at the same time. So that addresses both availability as well as restrictive constraint. Similarly, you can have user role assignment SODs saying particular user cannot be assigned to 2 different roles. And the other SODs that we can capture in GTRBAC include role permission, activation time SODs, and also what we call possibilistic role activation or permission acquisition. So briefly on these 2, possibilistic activation is needed when you have hierarchy structures. Actually, these 2 are needed for I and A hierarchy structure in presence of I and A hierarchies. So possibilistic activation, it is dealing with who can activate which role. So it captures implicit as well as explicit assignments. Implicit means by virtue of a user being assigned to a senior role, he can activate a junior role. But you want to be able to capture that within a constraint. And possibilistic is the permission assignment aspect, while possibilistic activation was user assignment aspect. So if you look at this example, a user in particular user set cannot acquire different permissions in P at the same time. So by using first order logic, we could express these constraints, which are essentially separation of duty constraints. And also we can say node, for example, node 2 users in particular user set can acquire permission in a given set. And we also employ time constraint, the notion of time with the SODs, and it's more intuitive. If you look at different forms of time, if you attribute SODs with intervals or periodic time expressions that we use in temporal constraint, we get 3 different forms of different strength that we can specify. For example, if you have this expression IP UAS, you are indicating a user assignment constraint.